Okay, so we're going to move on from proofs for a little bit and talk about some triangle facts. So our main goal is to eventually be able to prove theorems about triangles, but first we're going to review some things about triangles, okay? So like I said, we're moving on from proofs. We did our algebraic proofs. We've done some geometric proofs. Now we're moving on to triangles. So some interesting facts about triangles. First things first, the sum, hang on one sec, let's see. The sum of all angles in a triangle must equal 180 degrees. Okay. Number 2, triangles can be classified using sides and angles or both. So little arrow over here to the side. Okay. If you want to use sides to name your triangle, there's 3 different names that you can give your triangle based on the sides of your triangle. So the first one is called an isosceles triangle. Isosceles, which means that 2 sides are equal. The second name is a scalene triangle, which means no sides are equal. And the very last one is equilateral. Sorry, just had a brain melt. Geez. Equilateral. Equilateral, which means all sides are equal. Okay, so you can use the sides to name your triangle. You can have an isosceles triangle where 2 sides are the same, scalene where no sides are the same, or equilateral where all 3 are equal to each other. Okay, or you can use angles. So if I wanted to use angles to name my triangle, this is something that you are probably going to be familiar with. We have already talked about these names before. You can have an acute triangle, which means that all angles are acute angles or less than 90 degrees. You can have an obtuse triangle where one angle is obtuse. Or you can have an equilateral triangle. I mean, a right triangle. An equilateral triangle, I'm gonna add this here, okay, in just a second. So the last type of angle one is a right triangle, where one angle is a right angle. But with an equilateral triangle, not only are all sides equal, but all angles are equal as well. Okay, so an equilateral triangle has all sides the same and all angles the same. Okay, so the names, let's highlight them. You can have an acute triangle, an obtuse triangle, or a right triangle, an isosceles triangle, a scalene triangle, and an equilateral triangle. Or you can have a combination. You can have an acute isosceles triangle, right? Or an obtuse scalene triangle. You can combine them as well. So that's interesting fact number 2. Number 3, okay, the longest side is always opposite the biggest angle. Okay, which kind of makes sense when you think about it. If you have a giant angle like that, the longest side is going to need to be able to connect those 2 ends together. So that makes sense. Number 4, okay, the sum of 2 sides must always be longer than the third. So that space is really small, but the sum of 2 of your sides must always be longer than the third. Okay. Now this little piece right here, perpendicular bisector, is really the same thing. I think this is a typo and a formatting error. Okay, it just got repeated again. That little piece should be down below. Okay, so there's 4 interesting facts right there. The sum of all angles must equal 180. Triangles can be classified using sides, angles, or both. The longest side is always opposite the biggest angle, and the sum of 2 sides must always be longer than the third. Okay. So now let's talk about things that we can do with triangles. Whoops. Okay. So the first thing we're going to talk about is called a midsegment. A midsegment is a segment that connects the midpoints of 2 sides of your triangle. The midsegment is always parallel to the third side and is half as long. Okay. So if this is my midsegment right here, okay, this line is parallel to this bottom line below. Okay. And it's half its size. So let's say that this bottom piece was 4 units long, then the midsegment would be 2 units long. Okay. And also notice how this side, or this little piece and this little piece, have lines through them. That means that they are the same size, or they are congruent. Same with over here. This one and this one are the same size. Okay. Because a midsegment cuts it exactly into half. All right. The next one we're going to talk about is called a perpendicular bisector. So a perpendicular bisector is a line that cuts a segment into 2 equal parts and intersects at a 90-degree angle. So you can see that red line cuts into your other line and forms a 90-degree angle. Okay, that's what those little squares are. Sorry, I need to plug in my, there we go. So you can see right here, I'll highlight it in green. Those 2 little boxes means that we're forming a right angle. And this little line right here and this line right here means that those are the same size. Okay, so if this is 4, then this side is 4 because they're the same. Okay. Now we have an angle bisector, which is similar to a perpendicular bisector, only instead of cutting into a line, it's cutting into an angle. So an angle bisector is a line that cuts an angle into 2 equal parts. Okay. So you can see that this piece of the angle is 30, this piece is 30, the total is 60. So this red line here, that's your bisector. It's cutting your angle in half. Whoa. In half. Okay. Just like this bisector up above is cutting your line in half. Okay. So I'm going to highlight these words because these are all words that we're going to need to remember. So we have midsegment, perpendicular bisector, and angle bisector. So now let's solve some problems using those properties. Okay, so in exercises 1 through 4, DE is the midsegment. I'm going to highlight the same color as we highlighted that word up above, of ABC. Find the value of X. So what do we know about midsegments? They are parallel to the third side, and they connect midpoints of your sides. What else do we know from up above? I'm gonna right here. We know that it is half as long as the third side. Those are some things that it said about midsegments on the last page. Okay, so in number 1, I'm going to highlight the midsegment here in yellow. That's our mid-segment. The line that it is parallel to is right here. You can see that those are going the same direction. So we know that those two are parallel. What else do we know about it? Well, we know that this mid-segment DE is half as big as our line 20 or our side BC. Okay? So if I wrote that as an equation, I would say that 2 times x is going to equal 26. It's going to take 2 x's to equal 26 because it's only half as big. Okay, so it's going to take 2 of them to get all the way up to 26. So now I can solve for x. If I divide both sides by 2, x equals 13. Okay, let's look at number 2. So our mid-segment is DE, highlight that in yellow here, and our side that it is parallel to is XBA. Okay, we know that those are parallel, but we're trying to figure out what x is. So I'm going to set up another equation like I did in number 1. So I know that 5 is half of x, right? So 2 times 5 is going to have to get me to x. So really what we're doing is we're always going to multiply that mid-segment by 2, and that'll give us our final side there, our third side. So x must be 10. Okay. Just like over here, we times x by 2, we're timesing 5 by 2. Okay, let's see number 3. So number 3, it still says that DE is our mid-segment. So the line that it's parallel to is this one right here, BA. But that doesn't really help us solve for x. Okay? We know that a mid-segment connects the midpoints of your sides. Okay? But a midpoint is the exact middle, so it cuts it in half. So that means that E right here is the middle of AC, which means that this side right here, AE, is equal to EC, which means that x equals 6, because those are the same size, right? Just like over here, these are the same size. Okay. Now let's do 4. DE is still your mid-segment, and the side that it's parallel to is AC, but that doesn't help us solve for x. We know that E right here is the midpoint, so that means that this side and this side must be the same, so x must be 8. And same on this side, these are the same size. Okay. Okay, now let's talk about a perpendicular bisector. So now we're going to use this diagram to the right here and the given information to find the indicated measure. So each of these problems is going to be talking about this picture. So number 5, it says that ZX is the perpendicular bisector of WY. Perpendicular bisector, I'm going to highlight that. And YZ equals 13.75. Find WZ. So remember, a perpendicular bisector cuts your line segment in half, and it forms a right angle. Okay, so if you can kind of tell by this picture, we know that this side is equal to this side because that's what a perpendicular bisector does. It cuts them into equal parts. But now let's look at the triangle that was formed. So we have this triangle now, and we have, let's pick a different color, this triangle. Color side to side instead of up and down. Okay, these two triangles are the exact same. So when a perpendicular bisector cuts a triangle, it cuts it into 2 equal triangles. So what that means is that this side right here and this side right here will also be the same. Okay, because it's a perpendicular bisector cutting into a triangle. So ZX, I'm going to highlight that line in red. That's this perpendicular bisector right here. Okay. We know that YZ, which is this side over here, is 13.75. What is WZ? Well, I just told you that those two sides have to be the same because those are two of the same triangles. So WZ must equal 13.75 as well. Okay, let's look at number 6. I'm going to redraw that diagram so I don't erase what I just put on it. It's not going to be quite as pretty. It's not going to be pretty at all, but here we go. So here's our perpendicular bisector. Here's Z, X, Y, W. Okay, ZX is still the perpendicular bisector. So I'm still going to keep that red. I'm going to highlight that word purple. Okay. It says that WZ is 4n minus 13. So this side over here is 4n minus 13. YZ is n plus 17. It wants us to figure out the measure of YZ. Well, this is kind of similar to what we were doing before. These two sides are the same, right? Because this perpendicular bisector is cutting our triangle into two equal triangles. So that means that 4n minus 13 equals n plus 17. Now that's an equation I know how to solve. Okay, I want to get all my n's over to one side. So that's 3n minus 13 equals 17. And then add 13. So 3n equals 30. And then divide by 3. So n equals 10. That's not my final answer. It's important, but it's not my final answer. It wants me to find YZ. Well, YZ equals n plus 17. But I know what n is. N is 10 plus 17. So YZ equals 10 plus 17, which is 27. Okay. Finally, number 7. Draw this one last time. Again, it's not pretty. Actually, that one was better than the last one. Here's X, Y, Z, W. Hey, perpendicular bisector is still the same. I did not like that. We'll just, guys, I can't draw straight. There we go. Hey, our problem says find WX when WZ is 20.5. So that means this side is 20.5, which means this side has to also be 20.5. And WY, so this whole bottom part is 14.8. And YZ is 20.5. Okay. So we know that those two sides are the same, 20.5 and 20.5. Okay, but I don't really need that information for this problem. This problem wants me to find WX, which is down here. What do I know about WX? It's the same size as XY because a perpendicular bisector cuts it in half, equal halves. Okay, so I know that that whole bottom part is 14.8, and I want to cut it in half. So I want to find out what is 14.8 divided by 2. 14.8 divided by 2 is 7.4. So that means that WX is 7.4 and XY is 7.4. So WX is 7.4. Okay. All right. Last little bit. Let's talk about one more type of thing that we mentioned earlier. So we've mentioned the midsegment, we talked about some problems, we mentioned the perpendicular bisector, we did some problems. Last thing is the angle bisector, which I don't remember. Sorry, I'm going to scroll really quick. What color did I? Purple and blue. I want to highlight them the same so you can look back at them. Okay. Our angle bisector theorem. The angle bisector theorem says that if a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. What the heck does that mean? New vocabulary word here. Equidistant. Equidistance means equal distance. They kind of just shove those two words together. Okay? Equidistant means equal distance from the two sides of the angle. Okay, so using this picture, right, we have our angle bisector. Let me highlight it in red here. Here's your angle bisector. That's not what I wanted. I want my highlighter in red. There. And remember, angle bisectors cut angles into equal halves, right? So this is saying that this right here, I don't want that to be red. I'm messing up my color scheme. Oh, no, redo that. I know this doesn't matter to you guys, but it does to me. Okay, those two angles right there are the same because we have an angle bisector. So this angle and this angle are the same. Okay, if this theorem is saying that if these two angles are the same size, then these two pieces will be the same size. Okay. So if your two angles are the same size, then these two distances will be the same size. All right, that's what this theorem is saying. Now let's talk about the converse. You've seen a converse before. You saw it in our last set of notes. Okay, so the converse of the angle bisector theorem is pretty much going backwards. It says if a point is in the interior of an angle and is equidistant from the two sides of the angle, then it lies on the bisector of the angle. So here's that word equidistant again. We know what it means now. But what this is saying is we still have our angle bisector, but this says that if these two are the same size, not side, okay, then then your angles will be the same size as well. So remember, theorems and postulates are if-then statements. If something is true, then something else is true. Okay, so the theorem of the angle bisector theorem says if your angles are the same size, then the distance from the angle bisector to each side of your angle will also be the same size. The converse flips those two things around and says if those two distances are the same size, then your angles must also be the same size. Okay, kind of hard to wrap our brains around, so let's see an example. So number 8 says use the diagram and the given information to find the indicated measure. So this says that BD bisects angle ABC and DC equals 6.9. Find DA. So again, DB is a bisector. That's what it says here. Okay. ABC. And it says the distance from point D to C right here is 6.9. Okay, because this is a bisector, we know that these angles are the same down here. So if our angles are the same, then the theorem from up above says these two distances must be the same. So DA must also be 6.9. Okay. Let's look at 9. So BD is still the bisector of ABC, but now it says that AD, I'm not going to redraw this one, but it says AD equals 3Z plus 7, and CD equals 2Z plus 11. Well, since it's a bisector, we know that those angles are the same. If those angles are the same, we know that these distances are the same. So that means that 3Z plus 7 equals 2Z plus 11. And I can solve for Z. So I want to get all of my Z's on the same side. So I'm going to subtract 2Z. I'm left with Z plus 7 equals 11 minus 7. Z equals 4. So that's not my final answer. It wants me to find CD. Well, CD is 2Z plus 11. We know what Z is. Z is 4. So CD is 8 plus 11, which is 19. Okay. Finally, number 10. Find the measure of angle ABC when AD equals 3.2, CD equals 3.2, and angle DBC is 39 degrees. Okay, so this is the converse of the theorem, which says if your two side distances are equal, then those two angles must be equal. So our two sides are equal, so both of our angles must be equal. So the measure of angle ABC is going to be both of those angles together, right? Because ABC is the big angle. So it'd be 39 plus 39, which is 78 degrees. Okay, so that's just a little bit of information on our triangles, and we're going to get into a lot more with triangles coming up. Okay. Whoops, let's see.